Hi, in this video I'm going to show you how to set your single-ended impedance for traces on your printed circuit board in Cadence OrCAD or Allegro, and how to set your differential impedance for these traces. So I got this question when I was teaching at PCB West, and they were asking, the attendees in the session when I was teaching the PCB design process from start to finish. They weren't sure how to do this in OrCAD Professional. So all I showed them was you go to setup, cross section, and here we have our layer stack up for our printed circuit board. What you want to do is, while this layer stack up does apply to the board, here in the signal integrity section, you can actually double click on this column, scroll down here and set you can play with these impedance numbers. So for instance, it'll let you know that for this PCB stack up, with these layer thicknesses and dielectrics, like all these numbers matter and are taken into account. And this PCB OrCAD Professional actually does the calculation for you automatically for your impedance, okay? So you don't have to use an extra tool to do it. You can actually just have it do work for you automatically, or you can run the numbers yourself. Okay, here we have a trace width of 5 mils, right? And this is for single-ended impedance with this reference layer below it, this ground plane layer. You want to make sure you have this here, and you also want to make sure that you set this as not a conductor, but instead as a plane. So you want to change this from conductor to plane. Okay, and here as well, you want to set it to plane, because if you don't set it to plane, the numbers are going to get squirrely, right? And they're going to give you just the wrong information. Okay, so with that set, we have signal integrity, the column here, the width of the standard trace is say 5 mils. It's letting you know that from how these things are set up, the dielectric, the loss tangents and everything, that your impedance is going to be 75 ohms for this trace. Now, what if your target impedance needs to be your standard, say 50 ohms? All you have to do is type in 50, hit enter, and then it will recalculate a new trace width for the top trace. It's going to be different from the inner layer traces because there's on the top trace you have a dielectric as like one of your dielectrics is air and the other dielectric is below it is a different material. But in the inner traces you're going to have dielectric on both sides, which have different permittivity values. Okay, so anyway, if we set our target impedance, it will let us know and calculate for us automatically what trace width we need. So let me set this here for the internal layer. And you'll notice here that because of these difference in dielectrics, you're going to get different widths for the same impedance target, right? So this is how you do your signal impedance. All right, easy. So now what if you want to do differential pairs? Differential pairs are a thing. Very, very popular for high-speed signaling. You want to do differential coupling type and set it to edge. Then that's where you can define or see the differential characteristic impedance. So here we have, if you have a 5 mil trace that's separated by 5 mils edge to edge for the traces, right? Here, then you'd get a differential impedance of 75 ohms. But let's say I needed that to actually be 90 ohms for like USB, my USB 3.0 or something like that. So I would set it to 90 ohm differential impedance, and then it asks me which field do you want to be recalculated for this new target impedance. Do you want me to update the line spacing that you need to have, or do you want me to tell you a different trace width? Now, let's say I want to keep my trace widths at 5 thousandths of an inch because I get charged an extra premium at lower than 5 mils for instance. Usually 6 mils and above gives you not extra cost, but let's just run with it, all right? So I want to keep my trace width for the most part and just change my line spacing. So I click OK. Then it recalculates and tells me that I need to keep my differential traces 13 mils apart, 13.15 mils apart, edge to edge, okay? So that's how you would do that. Let me show you how you would do this. And you want to set this to edge for each of these. I don't typically use broadside coupling because it's usually not as effective for the most part. though sometimes it could be used. Let's say we want to change or just align width instead for this target impedance. What I would do is hit cancel. I would define and say, hey, I want my traces to be not closer than or not further away than, a certain number of mils, let's say 5 mils or something. Then it would say, well, for 5 mil spacing and 5 mil trace widths, you're gonna have a 75 ohm differential impedance. So I say, well, instead of 75 ohm, I want it to be 90, but this time you can recalculate the line widths and then tell me what I should have there. Then it's going to recalculate that. I have to scroll over and then see it tells me that I need an 8.29 mil trace width for each of my traces in order to achieve, at the spacing, in order to achieve a 90 ohm target impedance, plus or minus however much percent with a differential spacing of the 5 mils that I define. Okay, so this is how you can use the stack up manager, the cross section editor in Cadence OrCAD to automatically calculate your impedances for you without having to pull out the calculator and the equation sheet and the spreadsheets and all that stuff. Okay, this is the power of OrCAD Professional. All changes are made for cross section will be lost. Do you want to continue? Yes, that's fine. That's a nice little playground to get your impedances done correctly. Thanks so much for watching, and if you have any questions, leave them in the comment section below. See you till next time.